Problem number 5 asks me to find the linear equation that models the relationship between time and distance. Time is t, or I'm thinking in terms of x, and distance is y. In order to do this, I'm going to need to find two things. I'm going to need to find the slope, and I'm going to need to find the y-intercept, because those two parts are the missing parts of y equals mx plus b, which is the equation of my line. In order to find m, I'm going to determine what my change in y over change in x are. Now there's two ways to do this. One, you can plug in your points x1, y1, x2, y2 into your formula. y2 minus y1 over x2 minus x1, which will give me 80 minus 90 over 8 minus 4, which is negative 10 over 4, which is negative 2.5. Another way of doing this would be to say that I can see that my increase as I move from 4 to 8 is plus 4, and that continues as I move for the rest of them. And my decrease in my y values is by 10 each time. Remember, y goes in your numerator, so it'll still be a negative 10, just like right here, negative 10 over 4, and I still get negative 2.5. So that gives me my m, that gives me my slope. Now I need to find my y-intercept. I'm going to need a little more space, so I'm going to draw an arrow. I'm going to use my first point, my point 4, 90 from my equation, or from my table up here, and I'm going to plug that in as my my point into y equals mx plus b in order to find b. Y is 90. My slope, as I already calculated, is negative 2.5, and my x is 4. Calculating this, I get negative 10 plus b is equal to 90, add 10, and I get 100 is b. So that tells me that b is 100, and therefore the equation of the line is y equals negative 2.5 x plus 100. Remember, you're only substituting in m and b into your equation. Okay, so that's my first bullet point. My second bullet point says, how fast is the runner traveling? So I'm going to draw another arrow. And all I need to say here is that m is equal to negative 2.5 because I calculated that in the first step. But keep in mind, that got a little messy. Keep in mind that the negative 2.5 should probably have some units attached to it. So I need to talk about my units of y, which is in yards. You can see that up on your table. And my units of x my units of x is in seconds. So I'm going to write second. Okay. Finally, we're down to the third bullet point. I'm going to draw another arrow here. My third bullet point tells me, or asks me, how far the runner will be from the finish line after 32 seconds. There's a couple of ways to do this one. I'm going to try what I think is the easiest, and that is I'm going to extend my table. So I had 4, 8, 12, 16, 20, and then the next one would be 24, and 28, and 32. 32 is the number that I'm actually looking for, 32 seconds. So I should just be able to extend my y's as well. 90, 80, 70, 60, 50. That'll mean this is 40, and 30, and 20. So my answer is 20. The runner will be 20 yards from the finish line. After 32 seconds.